So let's just talk about the zero of a polynomial. What is the meaning of a zero of a polynomial? So let us suppose the question says what is the value of the polynomial at x is equal to minus of 1. So it means that we have to substitute x is equal to minus of 1 in this particular polynomial. So let us suppose we are substituting x as minus 1 in the polynomial. So we will get the answer as minus 1 raised to the power 2 minus of 3 minus of 1 minus of 4. So at the end we will get 1 minus minus is plus. So it is plus of 3 minus of 4. 3 plus 1 is 4. 4 minus of 4 is nothing but is equal to 0. It implies that p of minus of 1 is equal to 0. So at the end 0 is nothing but called as the value of a polynomial. This is called as the value of a polynomial. But we are talking about the zero of a polynomial. What is the meaning of the zero of the polynomial? This minus 1 is called as the zero of a polynomial. This is called as the zero of a polynomial. So always remember, whenever any particular value or whenever we will substitute any particular value in the given polynomial and the value comes out to be is equal to 0, then that particular point is called as the zero of a polynomial. So hence at the end the conclusion is k is called as a zero of a polynomial if p of k is nothing but is equal to 0. So this is all about the zero of a polynomial. So let's just consider any particular linear polynomial as px is equal to ax plus b, and we are saying if k is a zero of p of x is equal to ax plus b, then what we can conclude from this particular thing. So let us suppose if k is a zero of px is equal to ax plus b. So from the previous result we can say if k is a zero of p of x, then we can write p of k as nothing but is equal to 0 from the previous result. If k is the zero of the polynomial, then p of k should be is equal to 0, but it is given to us that p of x is nothing but is equal to ax plus b. It means that we are writing x is equal to k. It means we have to substitute x as nothing but k in this particular linear polynomial. So we can write it as pk is equal to 0. It means a of k plus of b is equal to 0. So let's just sort it out. We get the answer as ak is equal to minus of b, and at the end k is nothing but is equal to minus of b by a. It means that the zero of the linear polynomial, which is nothing but given to us as p of x is equal to ax plus b, is nothing but of the form minus of b by a, as k is equal to minus b by a is nothing but the zero of the linear polynomial ax plus b. So what we can conclude from this particular statement is that zero of the linear polynomial, which was minus b by a, can be represented as a constant term divided by the coefficient of x. You can see it that this b term is nothing but the constant and a is nothing but the coefficient of x. So hence at the end we have actually concluded a relationship in between the zeros and the coefficients of the linear polynomial, that the zero of a linear polynomial can be denoted as minus of b by a, which is nothing but is equal to the constant term divided by the coefficient of x. So this is actually a relationship in between the zeros and the coefficients of a linear polynomial.